Intervals 3. This is a review of how to handle the ones that involve more than one inequality. So let's start with the easy ones first. What happens when x is less than 1 or x is greater than or equal to 1? Well, think this is what the picture would look like. Open at 1 and heading left, closed on 7, heading right. So notice I just put my negative infinities in to remind me that whenever there's an arrow to the left, I start negative infinity. And whenever there's an arrow to the right, I end with positive infinity, because intervals are set up to look like number first, second number. And if you have an arrow, then you have an infinity either first or you have the infinity last. Notice this was an open circle, so this is still a parenthesis. That was a closed, and so it's still a closed bracket. Just another one that's just like it with the word or. Oh, by the way, the word or, you always use union for unite, meaning put together. Notice this time it's closed, and now this one's open. But always the negative infinity gets a parenthesis, the positive infinity gets the parenthesis. Now this has the closed bracket at -6 in the open bracket. Now let's look at something strange. What happens when I put 3 of these together? Notice this one will have an arrow to the left, arrow to the right, and that's a squeeze play. So I drew a picture so you could see what was happening. This is still said all. It's heading to negative infinity. So we would write it like it's an ordered pair, negative infinity, comma, -8. The infinity still gets the open bracket. -8's closed, so a closed bracket. This is normal. You just put in -2, then 6. This is open, and this is closed, so a parenthesis, then a square bracket. And in this one, the 11 is not included, so it's open. There's your positive infinity, and I write it as 11, comma, positive infinity. So let's do another one that's similar to this. So suppose I give you this one where it's going to be x is less than or equal to 4, -3 is less than or equal to x is less than 8, or 8 is less than or equal to, not equal to, start over, replay, 8 is less than x is less than or equal to 14. Notice the x is less than or equal to 4. You see one number, so you know you have to have an infinity. And since I'm going less, notice that's the less than symbol. We talked about that. That means negative infinities first, -4 second. It's closed. Again, these are squeezed. It's closed on -3 and a parenthesis on 8. And then over here, oh, it's another squeeze play. Oh, it didn't include the arrow. So it's open on 8 and closed on 14, and that's your answer. Now, before we go on, let's just talk about going the other direction. What if I give you interval notation? How do you rewrite it in standard inequality notation? Well, all I have to do is realize that this means go left. I showed it. You don't have to show that picture. That's just thinking. I'm just doing that to help you understand this. But this means the largest you are is 3. So x is less than or equal to 3. This one says the smallest you can be, because that's the number on the left, and the number on the left is the small number, and the number on the right is the large number. And it says the smallest you can be is almost 6, and you have to be bigger. Same idea here. I look at this one. It said, oh, this is the largest you can be almost, and that's the smallest. And notice these are both the same number. So literally, you want everything on the number line except -4. When you see something like this, it's appropriate to write it as just x not equal to -4. And when you see x not equal to -4, it can also be written like the above notation. Notice this says just less than -4. This is greater than 4. This is more cumbersome, but it matches this perfectly, and this tells you what you want. This tells you what you don't want. And that's the difference. It takes less time to say what I don't want than it says to take what I do want. Always acceptable answers for me, always. Now, if you're on a test and it says you must write with inequality notation, then you would have to do these two. All right, so now let's look at one that's a combination. Notice I drew a graph just to help you out, but this would say 2 or less. So this says less than or equal to 2, between 4 and 6 and equal to 6. This says greater than 8, but equal to 8. Very easy, very straightforward. The U's become ors, or ors become U's, going there. Before I do my final example, another one like number 7, I want us to look at another way that you could be able to write these inequalities, and it is becoming very popular, gaining popularity all over the place. I'm fine with whichever way you want to do it, but I need you to stay well informed so that you will completely understand and not be caught off guard. So, notice you could be given this notation or this notation. Look, these mean the same thing, correct? They mean this graph. But what's another way to write x is less than 3? It's kind of a combination. It says, oh, just write everything like it's a squeeze play. So you come down here and say, oh, put x in between. See, negative infinity left, 3 right. Put x in between, 6 left, and positive infinity right. Notice the infinities always get strictly less thans. And the only thing that can have equal to are actual real numbers. So 3 can have the equal to, 6 does not. Let's look at another one. So these are the two notations we've talked about, but here's the other way you can write this notation. You can say, I'm going to make it a compilation of these two. I'm going to stick the x right there in the middle. And so I'm going to say less than for both of them because that doesn't have an equal to. I'm going to stick x in the middle and write a squeeze play with the is less than symbol. And so I'd have negative infinity is less than x is less than negative 4, or negative 4 is less than x is less than positive infinity. Now this is hysterical because when you get into a college book, you will find literally in the same section, sometimes in different sections in different chapters, but it's hysterical. You can find in the same section, like an 8.2, that they use this notation to do one problem, this notation for another example, and this notation for a third example. It's a scream. And sometimes even in the same problems, they're mixing and matching these. So I need you to be prepared. So let's do number 7 this way. In number 7, I got to kind of try to get out of the sun here. So in number 7, we see that this is what we wrote before. So what am I going to do now? I'm going to come up here and say put an x. Negative infinity is less than x is less than or equal to 2. The same that we did before. 4 is less than x is less than or equal to 6. And 8 is less than or equal to x is less than positive infinity. I'm just going to come down and write it as a squeeze play. You know, the sun wasn't out. Again, every time I'm starting to record, so you can see that matches that one. This one doesn't change. And this is how this one could look. So now, let's do our third problem, and we'll do it both ways. So I see this, I've shown the picture, just the 4 is missing, and then the stuff in red is what's missing along with the open circle at 7. So this can be written two ways. You can simply say, for this one, oh, I wrote this wrong. That was supposed to, folks, I apologize. That was supposed to be a negative infinity. So I'm just going to, I don't have my thing here, so it's going to pretend like it's a negative infinity. Okay, so that would be written like this. X is less than, and then 4 to 7, and then x is greater than 9. Or here's your negative infinity. Pretend you put in the x, and so negative infinity is less than x is less than 4. And then this one doesn't change. It stays the same. Pretend, put in the x. 9 is less than or equal to x is less than positive infinity. Just remember, the infinities can never have an equal to, not because it's not legal to be equal to, it's because it's both equal and not equal to fit the definition. And mathematicians, not wanting to totally confuse non-math people, said let's stick with the one that's just the less than greater than symbols, simply because people would not understand the concept of equal to because infinity is not a number. So now you're ready to do worksheet 3.